In this video, we solve problem 8.1.14 from Essentials of Statistics, 6th edition by Mario Triola. We're given a claim. We're told that the claim is that fewer than 94% of adults have a cell phone. And then we're told that in a reputable poll of 1,136 adults, 86% of them said that they have a cell phone. And we're asked to find the value of the test statistic. So what I would recommend for this problem and all similar problems is first you write that claim down in symbolic form. So the claim is that fewer than 94%, that's a proportion of adults have a cell phone. So we're saying that the proportion is less than 94%. So the claim is that P is less than 0.94 if we write that percentage in decimal form. And then since that does not have a condition of equality, the null hypothesis is P is equal to 0.94. And that would mean that our claim is the alternative hypothesis. Okay, so this is what we're testing. And we're wondering if that's true. Now we're going to use this information. It says in a reputable poll of 1,136 adults. So our sample size is 1,136. 86% said that they have a cell phone. So that is a proportion for a sample. So that's P hat. So we have 0.86 there. And our question is, is this a rare value for P hat, assuming that the null hypothesis is true? So you can think of this in terms of the sampling distribution of the sample proportions. Remember, we covered that back in chapter 6. So you're imagining taking all samples of size 1,136 and you're computing a P hat for each of those samples, and then you're looking at how those are distributed. And then we're saying, if this is our sampling distribution of sample proportions, if the null is true, then the mean of the sample proportions is equal to the population proportion, which is this 0.94. And we're asking ourselves, if this is true, how rare is this? How many standard deviations is this above or below that mean? And in order to figure that out, we're going to compute the test statistic. So the test statistic is Z equals, and then we're going to start with the random variable that we're talking about, which is P hat. And then we subtract the sample proportion, or excuse me, the population proportion that we're testing against, because we're assuming that this population proportion is 94%. And then we're going to divide by the standard deviation of the sample proportions, provided that P is the true value of the mean and P is equal to 0.94. Now, a good estimate of the standard deviation of the sample proportions is the square root of P hat times, or P times Q over N. Not P hat, sorry, it's P times Q over N. Okay, so this is the formula that we're using. And basically this is getting us the Z-score corresponding to that value P hat. Now P hat is 0.86, the mean is right there at 0.94. So the P hat that we're looking at is 0.86, which is right there. And we're saying, okay, well, where is that relative to the mean? Well, obviously it's less than 0.94. So this would be a negative Z-score. So I'll take 0.86, that's my P hat. I'm subtracting that population proportion that we're testing against. We're assuming that that's a population proportion. And then we divide by this. And here you're going to use the P value that you're testing against. So we're, again, assuming that P is equal to 0.94. So we've got 0.94 here. Q is the complement of that. So if we take 94% out of 100, we're left with 6%. So we'll write that in decimal form. And then we'll divide by the sample size, which in this case was 1,136. So we have 0.86 minus 0.94, and then we're dividing by the square root of P times Q. And I want to put all of that in parentheses because that's in the numerator. And then I want to divide by the sample size, 1,036. And I get that. Whoa. That seems pretty significant. Even though it doesn't look like it on my picture, what this is saying is that if this is the true population proportion, then this p-hat of 0.86 is 11.35 approximately standard deviations below the mean. That's a lot of standard deviations below the mean. So it's going to be like way, way, way far out here. I drew it and it looks like it's maybe like between 2 and 3 standard deviations, but it's not. It's way down here. And that means that that's pretty, that's significantly low if this population proportion is truly 94%. But they didn't ask us that. They just wanted the value of the test statistic. So we've computed the value of the test statistic and we're done. We're done with this problem.